We take the fifth example. Is y triple dash minus 4y double dash plus y dash plus 6y equal to 0. We want to solve this one. So again we take y equal to e to power mx as a substitution, and we get the characteristic equation from this substitution. That's m cube minus 4 m square. We get here plus m plus 6 equal to 0. So we're having here this equation, and we want to solve this one. We want to factorize this one, and when we factorize this one, we will get here. Again, we take the first solution of this one, m equal to 1. When we take m equal to 1, we get here 1 minus 4 plus 1 plus 6, and this is not equal to 0. We take m equal to minus 1, we get here minus 1, we get here plus minus 4, we get minus 1 plus 6. This is minus 6 plus 6 equal to 0. So we say m plus 1 equal to 0 is a root. So then we divide this one, m plus 1, with as we did in the last example, and we'll get here the equation as m square minus 5m plus 6 equal to 0. So we get here as we did the last example. So we factorize this one further. We get here m into m, and the factors we are getting here, we have minus 2 and minus 3. We add, we get 5, we multiply, we get 6. So my factors are m plus 1 into m minus 2 into m minus 3 equal to 0. So I can write my roots. My roots are m equal to minus 1, m equal to 2, and m equal to 3. So there are three different roots. So I can write here my y is equal to c1 e to power m1x. This is my m1, this is my m2, this is m3. So here is minus x plus c2 e to power 2x and c3 e to power 3x, that's 3. So that's my general solution of the equation. So again here the difficulty was coming that we want to factorize this one. As I mentioned, that if you are good in factorization, then inshallah you will be able to find them very easily. So we get the trial method, and then we divide it and we get this quadratic equation, and we solve this one. So this was my example. Now we go to the last example. Our last example is that we want to find the solution of this equation number example 6. In example 6, we are having here the equation of the fourth order. They are very rare, but anyhow we are having a d4y by dx4, and then we are having minus y equal to 0. Solution of this one, as before, we substitute. Our method is we take y equal to e to power mx as a solution. We get the characteristic equation by substituting in this equation. We'll get here m to the power 4 minus 1 equal to 0. Again, you must be good in factorization. You have the formula a square minus b square is equal to a minus b into a plus b. We have in the formula a4 minus b4 is equal to a square minus b square into a square plus b square. Again factorize this one. We get here a minus b into a plus b into a square plus b square. That's how we can factorize this. So apply this formula. So on the left hand side I'll get here m square minus 1 into m square plus 1 equal to 0. Factorizing this again, we get here m minus 1 into m plus 1 into m square plus 1 equal to 0. So we factorize this one, we get this roots are m equal to m minus 1 equal to 0, m plus 1 equal to 0, and m square plus 1 equal to 0. So get the root m equal to 1, m equal to minus 1, and this one is a complex. So to show this one, if we're having the roots like this one, m square minus 4 equal to 0, so we get here m minus 2. I take here m square is equal to 4, and I take the root m is equal to plus minus 2 when it's a positive. So that gives me the roots m equal to 2, and we are having here m equal to minus 2. When we have m square plus 4 equal to 0, then we'll get here m square is equal to minus 4. So minus 1, I change it by iota square. When I take root of minus 1, that's equal to iota square, because when I take the root, I get here m square is equal to 4 iota square, and get here m is equal to plus minus 2i. We get here this is equal to iota, and minus 1 is equal to iota square. So when for this one, we get here m square plus 1 equal to 0 as explained. We get here m is equal to plus minus I. So I get here alpha equal to 0 and beta equal to 1. These are my complex roots. Now I write my general solution. So my general solution in this case, we can have here y equal to c1 e to power mx, m is 1, plus c2 e to power m2x, m2 is minus 1, plus c3 alpha x, alpha is 0, to e to power 0 is equal to 1. So we get c3 cosine beta x, beta is 1, plus c4 sine beta x, beta is 1. So this is my solution in case of the equation we are having here, this equation, and it was having mixed roots, it was having the real roots, and it was having the complex roots, and we having the combination of this one as a solution of our problem. So we have explained this one. I explained you the 6 examples. First example was simple roots which were not equal, 2 and 3, and this was the repeated roots. This was the complex roots. And this 2 example, we get here one root which was repeated, and here we having all the 3 roots were different. Here in this case we get 2 type of roots. They were real roots and they were complex root. Again, I would like to remind you that you can find more examples in my notes. You will get more problems in my notes, and notes are given in the description. The link is given, you can take from there. Then I would like that you just like the channel. Also click the bell icon so that you get the notification and you will be with us. If you have any question, any comments, you can just make the comments. That will help me to improve the lectures and make more useful for you people. Assalamu alaikum wa rahmatullahi wa barakatuh.